So the other day, we did a Maxcom Apollo 16E, and I put this Maxcom 21E mic, which had been kindly sent by a viewer, actually in working order, which is highly unusual for those, to it. I thought, you know what, we've got a Maxcom 21E that I bought as a scrap chassis, and I was thinking what we'd do is we'd sort it out as a scrap chassis. Now, I hadn't got a case for it, and I could always say on the video, if anybody's got a case for one of these, we can buy it off them. So when I came to look at this, there's nothing I can do with it at this moment, because the bracket which holds the audio chip is missing. Well, the bracket's the heatsink, so I can deal with all the other missing parts. There's a chip missing there, and the mic socket's missing, and so on and so forth, but all that can be dealt with. The driver and the output transistors, the output transistor is missing. That doesn't matter. The power connector's missing. We supply those anyway. But the other thing is, the audio chip's been ripped out of it. Now we might be able to get around that with a bit of jiggery pokery. But at the end of the day, I can't do anything with it. So one of our regulars who we deal with each other is Andy at Vintage Audio over in Stockport, and he said, I've got one, I'll sell it you. So he sold me a complete Maxcom 21E. Now this one isn't as pretty front, is it, as my scrap one? My scrap one's got, I think they're Maxcom 4E knobs. They're the right knobs. So I reckon we can do a bit of a swap there, and we'll make a really nice one. So thank you for Andy for supplying that. He's got two. I said send me the worst. So hopefully he has. These are plastics case. It's basically the same as the Maxcom 20E, but you've got a fairy light display instead of the meter. So what is it, the 4th today? 4th of July, June, not July, 2024. Maxcom MX21E, March 1982. 6, not 007, 344. Now, I like these sets, but I don't think there's any of the original range of Maxcoms I don't like. The connector's knackered, but we supply these anyway, so I'll be able to fit a new one. And of course we supply the made up leads, or just the plugs if you want to make your own. And the ones we supply are the factory original current production. It's a bought in part which Maxcom used at the time and is still in production. So not new old stock, they are brand new. But I do have to buy them 9 months in advance, so we have to try and guess how many we need. We've actually sold about 200 made up Maxon power leads, which fit these and the Colt 295 and the Cobra 21XFM and the Midland Precision series, all the 2781 Maxcom sets at the time. But 200 power leads over 2 years. So there you go. Some of you will say, where's all those sets? Probably shelf queens. So we're unsoldered that speaker. Did I switch the soldering iron on? Of course I didn't. We can see one of the tabs has come away, so I'll get that swapped for a brand new one. In the meantime, we'll run it on the crocodile clips. The fairy light display is done with a Texas Instruments bar graph driver chip. And it's right down there in the corner. There's like a perforated bit of the printed circuit board with that extra bit. Presumably they break that off and throw it away on most sets, like the 20E. So there we go. So although it's got a plastics case, It's got a shield plate there. We'll connect it to power through our trusty crocodile clips. Oh, you know what? We've got an old Maxcom power lead on the bench. We'll use it. With this going in, it's probably a bit safer to do it that way on this occasion. Right, we'll get it connected to the test gear. And there we are, lit up on channel 1. There we go, channel 20. So we're going to plug a standard replacement mic in. We'll do everything with that, and we'll only use that factory original on the air test at the end. Get the test equipment speaker plugged in, and we've got a hiss. So we've got a channel 9 switch. It puts up a 9 in the window there, rather than the display saying 9. And then we've got the high-low power switch on the front. So switch picture in picture on. Say that in case it doesn't appear. It appears on my monitor. Okay. So we'll start off on the 3-watt range. And we have nothing. Switch to the power level just in case it's that. And we have nothing. Let's switch to receive. 27 79125. Signal generator on. Deaf as a post. 10 microvolts. How deaf is that? So at the moment, for 12 dB Synad, we have 30 microvolts. That's seriously deaf. So let's go back into transmit. And I'm going to look at my ammeter. At the moment we're drawing 219 milliamps, going to transmit. We're drawing 850 milliamps and the radio is now transmitting. What was that about? And it's now receiving properly. Switch it off and on again. And it's now doing 0.76 microvolts, just like you'd expect. How bizarre is that? We got a something ropey on there, don't know. What am I doing? Yeah, 0.76. For 10 dB, 0.7. So it's like just what you'd expect. It's supposed to do under 1 microvolt. It is doing 1.35 for 20. Squelch. Full squelch. Never ever opens. Set threshold. .95. Frequency. Let's go over to the frequency counter. Transmit. 2779123. Deviation for what it's worth on here. Wallow. It's about 3.8. I'll put that in brackets in case it's misreading. Put it in the wrong box anyway. We're not doing the VCO. Of course, there's no method published. Transmit. And we've got 3.5 watts on channel 20. And oh dear, 1.6 watts on channel 40. And 2.5 on channel 1. Go back to 20. Yep, still doing 3. It's a bit funny, isn't it? Low power. .300 milliwatts. Back to full power. Current consumption is 885 milliamps. Right. On transmit, we're reading 3 on the bar graph, and for S9 on receive, we're reading S5 on the bar graph. Not applicable. They're okay, they're okay, they're okay. It doesn't have one of those. Well, there we go. That's a good start. Interesting that it's so low on some channels. So as ever, we're going to tune for the centre of maximum. I've not looked at the circuit, can't remember the layout, but I think we're going to be looking at these and that for transmit, and then round there. That's going to be the VCO. Let's go into 4 watt, into the 30 watt scale. Centre. Just going to touch that one. I think it's received. No, it isn't. It's transmit. I'm going to touch that one, which I'm convinced is received. That's a solid 3.5, and see whether we can just bring it up with this one. Not quite, it's about 3.8. Now on these, I don't like this, but these airspace coils are part of the tuning. Check they're in the right position. The coil stretcher's not been at them. Well, I think we've got about 3.9. See what we are on the other channels. I'll come back to it when it's cooled down. Channel 40, 3.6. Channel 1, 3.6. So it is balanced. Right, so we want the bar graph meter to read 4, seeing as we're doing just about 4 watts, which is going to be the transmit one. It's guess time. Well, it really doesn't matter what we upset. It ain't that one. It is, it's that one. Chances are the other one's going to be receive. So is that deviation? Because one's going to be low power, isn't it? So go to low power. That. The one I was fiddling with is now 400 milliwatts. We'll come back to deviation. I'll tell you what, we'll find it on this test set. I'll just use the little oscillator. Probably going to be that one. Wallow. A bit more. I'll set it up on this test set and then we'll test it with the other one. Wallow, 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 wallow. That's it. Right. So far, so good. There must be a dry joint on the back, which was causing it to do no transmit and being as deaf as a post. It's somewhere aerial-wise, so it's going to be around this initial area. So I'll get Mr. Chippy to look at that. Though I think we might have a look at it in a bit. Let's do the receive. So there's nothing wrong with the receive, but it still needs optimising. So we'll put the cyanide meter. No, I'll tell you what, we'll put the oscilloscope up, won't we? With 100 dBs, 100 microvolts, so we've got a decent trace for the detector. And the detector coil is clearly that one. Just a fraction. It can make all the difference. So let's go through the front end. With the cyanide meter. That was the right position. Now is this receive? Yeah. Well, I messed with that one, but I messed with it after we did the readings. Just turn the attenuator down. And that is probably it. Check we're on frequency with the test set. 2779130. Near enough. And check the frequency of transmit. 2779115. I'll just pull that up a fraction. Absolutely near enough, but we'll just do that while we're at it. Right, let's see what we've got now for sensitivity. So for 12 dB, or actually worse, I'm going to go through this again, but with me altering the detector, it can make it worse, but make it better in intelligibility. Just check the detector again. Right, see what we get now. So for 12 dB, yeah, it's 0.95. Well, it's in spec, but there we go. dB, 0.85. No, surely 20 is going to have improved. Is the same at 1.35. Just going to check that, and it did affect transmit, I'm sure. Yeah, so go back to transmit. Okay, so VCO, transmit, 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 receive front end, IF, and the detector. And there we are. Squelch. Right, I've got squelch on full, 100 microvolts, and that's going to be the squelch preset. It is. I think that wants cleaning. No, it's set up fine this time. I think the switch cleaner needed to take some effect there. So on receive, 100 microvolts for S9 is going to be that preset. Well, you'd think it was. Okay, must be that one then. And that's the most it'll give. It does have 5 stages though. It's not just 4 like some sets, but it's not how I would normally set them. It is 3. It's 150, 60, 180 microvolts for S9, so it's what you'd call a lazy needle. So it's 180 microvolts. for 5 bars. Squelch now is 100 microvolts. Oops, I put it in the wrong box. And for threshold, try again. That did not work out very well. It is actually 1 microvolt. Right, so I'm going to look at that for dry joints. In fact, we'll do that together. I can't say I've had this before with these. So we're actually looking. I'll just turn the volume down a little bit. So the aerial connector has this decoupling capacitor. It has a link which goes down to the printed circuit board. So I'm just going to look at around here. Pause video. Okay, well, I've been through that. Nothing glaring, but we'll be leaving it on overnight. Make sure it still works tomorrow. Power back on. Check the sensitivity now. 0.92. It was 0.95 before, you know. 0.85, 0.85. Yeah, it's not changed. Need to do that. And we need to swap the fronts. Get the power off. Pull the knobs off. I'll be getting the piece of string behind this. Anyway, in the meantime, I'll take some of these screws out. Oh, no, this is my way. Tell you what, let's fiddle with the scrap set. The sad thing is, I bet this was scrapped for a really silly fault. Right, so they are screwed to the front panel. And that's a single screw. I may as well go and clean that whilst it's off. Right, transplant is done. Get those twisted together so it helps with hum. Not that these sets suffer from hum. And then we'll find out whether this speaker works. It has struck me that I've got a Maxcom 20 which I think's got a broken front. So it's the same image as this apart from the fairy light display bar graph. So I think the missing parts which could make up this chassis could come from the broken 20. It's always a possibility. Yeah, that works. I've still forgotten to do the power connector. Oh yeah, so that looks a bit smarter with the other front instead of the one on now the scrap set. So the thing to do here is to try and... We've got a tool to get these out. Is it on here though? And why should it be on here? I'll go and get the extraction tool. So you can get these sets of removal tools from AliExpress for 89 pence. I think it's the blue one on these. Sure it's not the red one. You never know. Alternative, it's chop them off and put new pins in. Which when you buy these connectors from us, of course it comes with new pins. That's one out. That's two out. So let's remember it's red towards the aerial socket. So we just need to manage to get this out somehow. That's that way, is it? So it's the rib bit to the top. It's exactly the same. Clips into position. Just make sure that these barbs aren't going to make the pins migrate. That's fine. But there is enough wire here to chop off and solder or crimp new ones on. There we go. Of course I've got the 89 pence, so it's the red one for these sets. Right, so that should now mate up with there properly. There we go. Job's a good one. You can see one of the things snapped off here. You could glue gun it, but I think we do them for £1.99. See if we can screw it back together. Never checked the deviation, did I, on the other test set? You can see we're going to be opening it up again. Might as well take picture in picture off. Wow, it's too high. I'll know how to get into this soon. Wallow. 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 That's it. Right, we'll put it back on the Marconi test set, which obviously isn't playing ball today on deviation, which is why we double check. Put picture in picture back on actually. Wallow. Wallow. According to that, we're doing 5, but we're not. Okay, so it's lying today. Final check. Right, so put one more screw in. There is one missing. We'll have to deal with that at a future date. And put it onto the aerial. Might as well turn the test gear off. One on a Roger. Right, we'll see whether we can do another on the air test today. So there we have it. Maxcom 21E. 3.8 watts. And the current consumption 937 milliamps. We're done. You don't see many of these, so thought you'd like to see that. Thanks for watching. Maxcom 21E from 1982.